Hi team, this video is in a submission on my project of AI plus product management where we will build a model to predict the electrical energy output of combined cycle power plant which uses a combination of gas turbines, steam turbines and a heat recovery steam generator to generate the power. Although we had an options here to choose a model between AI, Python technology or by using an Excel where I choose to proceed with the model of AI assistants, which I believe which will help us to streamline the process. The benefit of using an AI assistant would be for to build this model with the help of precision, which will help us to make the right decision with the most precision and as compared to the rest of the given model. Now our next concern is what kind of predicting modeling would you think that we would most straightforward to implement in Excel by given its formula based nature. We understand that, but apart from that, linear regression is a great example of the model that can be implemented in Excel. It's a fundamental statistical method that help us to understand the relationship between the variables. Now considering the next path with determining which features are most important for training a model. Although all the given examples, I believe that ambient temperature and exhaust vacuum are most likely to be most influential predictors of our net hourly electrical energy output, where ambient pressure and relative humidity may have the secondary effects. I believe that higher the ambient temperature reduces both the efficiency and maximum possible outcome of combined cycle power plant, mainly due to its thermodynamics limit, reduced air density, and less effective cooling. Now, considering the next part, like describing the key considerations when choosing an algorithm for a model. Since we are predicting a continuous value like electrical energy output, we are dealing with the regression problem here. For such problem, especially with a data set of this size, we often prioritize algorithms that are both reasonably accurate and easy to interpret. I believe linear regression is indeed an excellent choice for this type of problem. Its simplicity means it's computationally efficient and very easy to interpret, which is a big plus when we want to understand the direct impact of each environmental factor on our power output. Now let's think about the output we are trying to predict, the net hourly electrical energy output. When we build a model to predict a continuous value like this, we need a way to measure how well our prediction matches the actual value. And what kind of output metric do you think would be suitable for our evaluating the performance of our model for both RMSE or MAE and R square for a complete picture? I believe RMSE, root mean square error or mean absolute error are individual crucial for understanding the magnitude of a prediction error, and R square help us to understand how much the variance in the energy output and our model explain. Now next, describing how to split the data to train a model and to perform the cross validation. As it into at least two parts, a training set and a testing set. The training set is what the model learns from, and the testing set is used to evaluate how well the model performs on a data it hasn't seen before. Having multiple subset of testing is indeed a core idea behind technique called cross validation. Instead or just of one test, cross validation involves splitting your data into several parts, using some for training and some for testing and other for validation in a rotating fashion. This helps us to get a more robust and reliable estimate. We initially divide, so this whole procedure we usually called a k-fold way. We initially divide the data into k equal parts, folds I mean, and in each round we use a different fold of variation and the rest of the training. This way, every data points get to be in the validation set exactly once. By rotating which fold is one of the validation and training on others, we get much more reliable assessment of our model performance, reducing the bias that can come from a single train set split. Thank you.